Okay, welcome to the last question in section 6.2, finding the volume using the washer and disk methods. Here we have a region between four functions and we want to rotate it around x equal to 1. So let me just have a quick sketch of this function. The first function, the blue one, is very simple because this is just the usual line y equal to x. And then we have x equal to 2. Let me say this is 2 and this is 4. So we have two lines up here. And the last one is y equal to 0. So it would be this one here. And then my region will be this one. That's my region. And my axis of revolution would be this one. And then the axis of revolution would be x equal to 1, which will be this line here. X equal to 1. As we do before, we need to find the outer and inner radius. R out square minus Rn square. Of course, here we need to find, is it dy or dx? It's depend on our choice of functions. Let's see which one we will choose. In order to find R out, you need to draw an arrow from the axis of revolution, which is this one here, to the maximum you can go inside the region, which is this one. Now look at your arrow. Is it horizontal or vertical? Yes, it is horizontal. So everything should be in terms of y, because horizontals with y, vertical rectangle with x. Now you have to tell me if it's in terms of y. We need to know what is the right function and what is the left function. The right function is clear because it's just x equal to 4. And the left function, again, it's clear because it's just the red line, which is 1. That will give me the R out. Doing the same with the R in. With the Rn, this is the first function and this is the second function. Okay. And that will be what? Will be 2 minus what? The red one, which is 1. So far, everything is very good and nice. Except that the limit of integration. Look at the R out. If we move it down, it will reach at 0. So everybody would agree this is 0. Now, if we move it up, this line will go up, 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 up until where? Where should it stop? I think I sketch it. It will end up until the R out will be the same up to here. And then we should change because the Rn will be a different Rn if we go here. R out will go all the way fine from here to here, but Rn has to change. Where it will change at this point. And how much is this point? Is the intersection point, which is 2. So at 2 we have to stop, and then we have to start again. From the 2 to 4, R out will be the same. It would be 4 minus 1. But the Rn now will start to change. Why? Because it will be the blue function. That's why we have the blue function, which is y minus. If you do this, it's the idea is just take your region into two regions if you want. We can say it's two regions, because now everything will be fine because you have two different regions, and for two different regions we have two different integral. You add them and you get what you need. Please let me know if you have any question in the comments, and by now you can go and solve exercises 6.